Hello, everybody. Welcome back. My name is Michael, and I hope you're having a wonderful day so far. Today is November 30th of 2024, and we are jumping right back into Python, learning and studying and teaching myself. I am ready to go here. I've been relaxing kind of all day, um, ready to do some learning. I just admittedly woke up from a bit of a nap, so I am a little bit groggy. Still trying to wake up a little bit. I am late getting onto the stream here. My goal was to start at 5, but that obviously did not happen, unfortunately. But we are back nonetheless, and hopefully we can learn some Python here. So let's go ahead and let's CD into repos and CD into DSA. CD DSA-py code here. Alright, let me make sure I get the stream selected here on my OBS. Nice. Alright, let's bring this over. Ooh, not what I meant. Quit. Perfect. Alright. Chapter 2. 1. Done with that. We're on chapter 2 here. Alright, let's just go ahead and get started. And as people trickle in here, we can, so yesterday we did a 4 hour long stream. It was really successful. It had a lot of interaction. We actually gained a lot of followers and subs on the channel. So big shout out and thank you to you guys for supporting and interacting in these streams. That's the whole point. But let's go ahead and let's just jump right into this, right? So we're on R29, R2.9 key.py, right? So this says to implement the sub back into here. Okay, so 2.3.3 is, let's go back and find that. 2.3.4 sequence iterator vector. Okay, so this says it says implement the sub method for the vector class section 2.3.3 so that the expression u minus v returns a new vector instance representing the difference between two vectors, right? So we kind of need to do the inverse here of this dunder length, or dunder add. When we add two vectors, we can add them together and sum them, else we can do this. So let's go ahead and we will define this as def dunder sub, right? It's going to take in self with other. So it's going to say if length. So the objective is to return sum of two vectors, right? But not sum, return the difference. Okay, so we're going to first say if the length of self does not equal the length of the other provided, then we're going to raise a value error, right? And say dimensions must agree. So vector self and other must have the same length to be operated on, right? So that's what takes care of that. So we return the length. So if the vector has a length of self and that does not equal the length of the other vector provided, right? We return that they must agree and we raise that value here. We cannot perform any operations. Okay? So then we have result is equal to vector, right? Length of self. Start with vector of zeros. So we create a vector based on the length of self. Okay, so this starts you off with all vector of zeros. This creates a vector with zeros for all places, or for self, right? So if the length of the vector, right, this is just creating a placeholder of all zeros for now. Hey, it's a Mete. I can't. I'm not sure how to pronounce it. Mete Asian. I'm not sure. Let me know how to pronounce your username. I'd really appreciate it so I can reference you appropriately. But thank you so much for joining and leaving a comment on my channel. I appreciate you joining and coming in. How you doing this evening? So we're creating a temporary, just a result, blank. Basically, we create a vector based on the length of the cell. So we'll create it'll basically create vectors look like this. It'll create, if the length of self, the vector originally is 4, it'll create 4 placeholders like this, right? Right. So that'll be our vector result in theory. So now, for j in range length of self, yeah, okay, so then we're going to say for value in range length of self. So what this does, right? So rather than, we're obviously gonna do the difference here rather than add, but for j in range of self, in range length of self. So this says for every value in the range of the length of self. So right, if we have a vector that looks like this, right? This is our vector. It's going to say for every value in the range of the length of self. So if the length of the vector self is 4, right? Meaning that our vector has 4 places. Range would be 0, 2, 4, 0, 1, 2, 3, right? Places in our list. And then now we're going to result of j, result for value in the range of length of self. We want to take, for every value, yeah, we take the result at that index value, right, is equal to, so this, we're at this first place, this is equal to, well, what's it equal to? It's equal to self, of value minus the other value, right? And then we return result here. Now, can vectors go negative? I think so. So I believe that this would be appropriate in this circumstance. Hello to the people in here. I appreciate you coming in and joining on my stream this morning. Today is November 30th of 2024. We're just jumping in with data structures and algorithms in Python. This book can be found online in PDF form. It's a textbook often taught in many college courses for DSA and Python. Or if you would like, I have a Discord linked in my description. It's completely free. I've just set up kind of like a study ground that kind of provides all the resources that I'm using personally to study independently. And if you would like access to all those, just feel free to just join that Discord and you can gain all that access. Um, cool. So I think that this works. So let's go ahead and let's throw it into the gypt to see if it has any recommendations. The sub method defines how to subtract one vector from another for a custom vector class in Python. Here's a breakdown which each part does. Checks for dimension, yep, result. Initialize a new vector result with zeros, element-wise subtraction, iterates through element of the vectors, through each index of the vectors and subtracts the corresponding element. Okay, cool. Notes, potential and check other vectors in instance. Okay, I think that this is appropriate. Cool. So this one was kind of easy because you could reference the dunder add method that you already had, right, and just kind of switch this. But it was kind of good for us to break down what each of these kind of these for loops meant, because they can be kind of challenging, like for value and range length of self. You have to understand that we're trying to find, this is what a vector looks like, right? This is what the result vector looks like. So if we are trying to find where for every value if we have the length of self, so the length of our original vector is 4, then we have range of our length, so 0 to 4, so 0, 1, 2, and 3 spots in our vector. And for every value in that range, we're going to go ahead and do the result of the value is equal to, the self minus the other value. So that's how we individually isolate each one of these vector values. So it's really important that we kind of understand this range length of something, because it seems like when we're talking about DSA and algorithms, this comes up quite often, like range length of, while, yada yada, range length, range, all this kind of different sort of, determining values in a data set is pretty key, right? Cool. So that answers the 2-9, I believe. Takes care of that one. All right, we got some comments. Hello, we got people back in here. Copter, I appreciate you coming back in. Welcome back. Hello, this is my weekend. Awesome. And I appreciate you coming in. Happy Saturday to you. William, thank you for coming back. We met last night for the first time, and we are back. All right. Cool. Let me go ahead and check something real quick. Gotcha. All right. We can move on from this problem now. Let's go ahead and take a peek. Oop, a little bit too far in my scroll. Oop. There we go. All right, implement. Pardon me. So this is R2.10 key.py. All right, Jerson Diketama. Hello, I'm sorry if I butchered your name completely. I'm really bad at pronouncing those, but what LLM app are you using? I'm not using any LLM app. I'm just doing some independent study of data structures and algorithms in Python. I'm learning as a independent student, teaching myself all this kind of stuff. So, all right, cool. It doesn't like that because we don't have a class actually vector here, so I might have to go copy it to get that to be okay, but it's fine. Let's go ahead and move on to 210 here. So 210 says implement the dunder neg Sky, you okay? My dog's kind of breathing funny. Sky, come here. You okay? Come lay down. You all right? Oh, got you. I'm sorry. This app right here, this is just ChatGPT. ChatGPT, that's what I like to call it. It's just if you download it, you can press Option Space, and it comes up kind of like the Spotlight. So after I kind of do these problems, I like to plug it in just so I can get a little bit of a check on myself. I don't like to obviously copy things that it says, and I I like to learn from what it says and use it more as a tool rather than like a hack. Not really. That's my kind of style. I want to learn this stuff. Okay, so what's going on? If you can hear that, that's my dog. She's breathing kind of funny. Implement the Dunder-Neg method for the vector class so that the expression minus vector returns a new vector instance whose coordinates are all the negated values of the respective coordinates of v. Interesting. So let's go back up to that vector class. I think it's right here. I'm doing it too. All right. Where to be? What's going on? It's making me a little bit worried. Okay. So we need to implement the neg method for the vector class so that the expression v returns a new vector instance whose coordinates are all negated values of the respective coordinates of v. What is this expression hyphen v? Is this supposed to be subtraction? A bug. Get here. All right. Let me go back to the original problem, I guess, and see. Oh no, okay. Is that the expression negative v returns on its own returns a new vector value. Okay. So we will define a Dunder negative, which takes in the vector itself. And then for what we're going to do is we're going to say a new negative neg vector is equal to the vector class, right? It's going to make the vector for the length of self, right? So we're going to make a vector, a blank vector, a new one, right? We don't want to we don't want to edit. I think we want to keep returns a new vector, right? So we don't want to edit and return the same vector. We want to edit and return a new vector. Schwaz, thanks for joining back. I appreciate you coming in and saying hello. Good to see you again. Yes, we are back. All right, so we're going to create this new negative vector by using our vector class and creating a blank vector with the same length as self. We are then going to for value, right, in the range length of negative of self, similar to the problem before, right? So for value, we're going to make the new vector value equal to for every value in the range of the original vector of self, why would we need to do range and length of self? for every value in the range and length of self. Why couldn't we just say self itself here? You get what I'm trying to say? Why couldn't we just say for every value in self? Why do we need to include the range length of self when we already know that self will have some sort of vector range? Does that make sense? Does anybody have any thoughts about that? If we're trying to index into every range of the vector, why do we need to say range length of self? Length of self 0 to 4. So I think we just need to say for every value in self, negative vector is going to be equal to negative vector at that index value for index in self, the negative vector at that index, right, is equal to self at that index times -1. Does that make sense? So the whole point of this is we're trying to just return we're given a vector, right? We are trying to return a new vector, right? Negative vector. I'll just make this more obvious. We'll make it the new negative vector, right? Right? So we're going to create a new dummy, like a new template placeholder vector with all zeros that equals the length of the original self vector provided. And then, for every index value in self. No, this says for value in self. We need, because we're trying to find the index value. That's why we have to keep this. So range length of self means that you're accessing the index values. If you were accessing just the value of self, you would just be taking that value directly of the vector itself. Now, by doing range length of self, we are actually getting the index value of that place. So the new negative vector at that index value, so the first place, is equal to self at that first place at that index value times -1. And then we're going to return new negative vector. Right. Samuel says you could have done index equals self times -1. For index What do you mean, Samuel? Can you give me a little bit more detail? Appreciate your comment. You could have done index equals self times -1. So obviously something right here. Index equals, for index is equal to the self but we need to assign that directly to the new negative vector, right? So for index in self, so Samuel, I think that's what we were trying earlier. See, if I were just going to do a for loop, for index in self, like if I were to go like this, right? Instead of say what I have here, right? So I'm just going to go ahead and move this down. If I were to say for index in self, right? Well, what am I actually doing here? Let's go ahead and show what a vector looks like in this circumstance, right? So the vector in set, like the self vector, the instance itself would be, let's just make going up. We have like 4, we have 1, we have 6, and we have 5, right? So this is a positive vector, right? So for index in self, technically the index representation is just the same as saying for value in self, because self, we're just accessing the individual values of the list. So index, by saying index, it would, index would save the value of 4. Index would then save the value of 1. It would then save the value of 6 rather than the value of 0, 1, 2, and 3 for the index value. So by doing range length of self, right, we are instead saying, okay, instead of accessing the values of self, we want to take self, the length of self, which would be 4, right? This would be 4. We want to take the range, so the range would be 0 to 4, right? So this would consist of values of 0, 1, 2, and 3. So for 4 total values in our list, because 0 indexed. So now we are appropriately capturing in our index variable here the index values rather than the actual values in the list. Gotcha. So yeah, exactly. I think you kind of figured it out as well. That was kind of not the way that we want to go about it. So, but that's perfect. We're both learning on this as well. Cool. So now I think that this would work. So no, all good, Sam. That it's perfectly fine. We want to go down those rabbit holes because then it just further solidifies this concept of range length self by talking through that and showing that example. Me and everyone else in here, and the small amount of people that it is, but it's great that we have these people in here. Get to have another refresher as to what that meant, and now I'm sure we're all on a more now we're probably all on a better or more closer, similar, same page to each other, and so we can move forward. So that was great. Okay, so now what we need to do is I think this is done. So let me go ahead and go like this. Your implementation of the Dunder-Nig method is almost correct, but needs some adjustments to work seamlessly with the vector class. As outlined in section 2.3.3 of the textbook, you're referencing below is the correct and clarified version of this method. Don't show me the correct way. Instead, coach me through what I did wrong. And I will paste in my corrections. Okay, got it. So let's work through this step by step. So observations, you are creating a new vector with vector length self. This likely doesn't match the constructor of the vector class, which probably takes coordinate values directly, just not a length. No, that's not true. It's kind of inferring. Setting values, you're trying to assign negated values, new vector length index, but does your vector class support item assignment using indexing like this? Check whether, yeah, we have set item, okay. Efficiency, you're iterating through the self range length self, which assumes self has a length method. Okay, so this is just adds some questions actually to how our vector class is set up rather than our code. So I think our code itself actually is working appropriately. So Maybe I will just go in here. I don't want to add in the whole vector class. It's going to be so annoying. Oh. Like, I'd have to add in all this junk. Okay, let's just see here. See you, Copter. Thanks so much for joining. I appreciate you stopping in. Okay, so self. This guy. Okay. We're going to take this guy. Just cleaning this up for the next users when I publish this. Sorry, guys. Give me a second to format. So now we have a vector class. So now it's not going to be as picky, at least. So okay, cool. Now I think we can move on now. Okay. Cool. Back up here. That was 210. All right. R211 key pi. Nice. Okay, so here we go. In section 2.3.3, we note that our vector class supports a syntax such as vector equals u plus this, which is the sum of a vector and returns in which the sum of a vector and list returns a new vector. Okay, however, the syntax v equals 5, 3, 10, -2, 1 plus u is illegal. Explain how the vector class definition can be revised so the syntax generates a new vector. Okay. So this one's more conceptual. Like, how could we revise the vector class to you guys have any ideas? Feel free to answer the questions in the chat if you guys know. Like, this is for all of us to be working on here. So why in this case would by just swapping, subtracting over the value of the list and then adding over or subtracting over u. Oh, okay. So actually the only thing that's different between these two is that u is proceeding first and then the list provided, and in this second example the list provided is being first and then u is illegal. Explain how the vector definition class can be revised so the syntax generates a new vector, right? So let's go ahead and take a look at that vector class. Oh, we got lucky there. All right. TT, can you please send me your Discord profile? Yeah, it's just in the description of the stream. So let me know if that link is working. I updated it before I started. So if you would like it, it is there. So this we're trying to, it would be, in the vector class, what would be, it's not set, it's not get item, it's not initialize. We wrote it that our vector class supports a syntax such as that. Where is that defined in here? It's not in the dunder add. I mean self here plus the other provided. Okay, I guess it is in the dunder add, right? So self is initially listed first. How could we syntactically say that it's okay to provide self second? Samuel says you would have to implement a reverse addition operator. Okay. So the dunder, is it R add? Right? Is it R add? Let's look. Reverse addition operator. Looks like you're asking about implementing the reverse of the addition operator, i.e. plus, for your vector class. Specifically, the reverse addition operator corresponds to the dunder R add method in Python. When to use dunder R add? In Python, the dunder R add method is called when the left operand doesn't support the addition operation and the right operand, your vector instance, has the dunder add method. This typically happens when you try to add a vector to another object on the left side that can't be added directly to a vector, but the vector class can still handle the addition. For example, if you have something like result equals non-vector object plus v, where v is the vector class, if some non-vector object doesn't have its own dunder add method, Python will fall back on the reverse add method of vector v. How can you implement the reverse addition operator under R add? Check what type you're reading. So you could say, explain how the vector class addition can be revised so the syntax generates a new vector. Samuel says you would have to set the left into a vector. So how exactly would you implement the dunder R add here? So it says self and other if isn't other vector. Huh. Okay, so what you would have to do, you could either implement this whole function, right? You could implement a dunder R add, or could you simply vector other right off the jump? You know what I mean? Could we not just simply say vector, like on line like in between 24 and 25, can we not just say vector other? Right? Because if we transform other into a vector rather than a list, it will support the add operator, the dunder add, by adding to the right. Adding from the left, I mean. You will add onto this. What do you think, Sam? TT says, no, I want to join your Discord. Helping me. Gotcha. Yeah, the Discord link is just in the description of the stream, so feel free to check that out. So could we not just vector here, just vector the class? Could we not just vector other in our add. Yes, you could absolutely right. If you're already implementing the dunder add method, you expect the other operand to be of the type. You could convert the vector to such as a scalar or other iterable. Then you need indeed to try to convert the other into a vector inside your dunder add method. Why vector other works? If other is a scalar, like an integer or a float, it makes sense to treat it as a single value that should be added to each coordinate of your vector. If other is an iterable, like a list or another vector, you can create a vector from it. Okay, exactly. So perfect. So what you can either do is you could implement the whole, another dunder r add to catch that instance, but based on this code right here, 20 through 27, our dunder add method for this class, we already are checking if the other vector provided is the same length as self, meaning that the vector, if self has 4 values in it of 0, 1, 2, and 3, this is how vectors are represented, and it's checks that make sure that the other vector has a vector length of the same, right? And if it does, then we can proceed. We don't get this value error. So we already know that the other, right, if this is self and then this is other, if this is other, right, if we already know at this point that other and self are of equal length, then we can infer that other will be supported within our vector and will then be supported within our dunder add method. So what we can do essentially is after that check happens, we can just take vector and convert other, the list other provided that was provided by the user, into the vector, and then perform the addition of, the vector of this will become a vector, so this will become, v plus u equals new v, pretty much. Or in a sense, like new variable, like j plus u equals v, rather than just a list. It'll become a vector object. So what we can do is we can say, let me keep this. I'm gonna go that. So what we'll say is you can either implement an entire new method, new dunder r add method to catch when the addition order changes against when the addition order changes or because dunder add already checks if the length of other, right, is equal to the length, so we'll keep it self is not equal to the length of other, we can just convert other into a vector object and successfully perform the addition of two vector objects together, right? Does that make sense, everybody? Yeah, other equals vector other would be perfect, exactly. Let me know if that doesn't make sense for anyone. We can go over that again. But essentially, is we don't have to implement a whole new method of radd under radd for when the addition order changes from a list to a vector or a vector to a list, vice versa. We can instead just convert other directly into a vector because we already checked to make sure that they're compatible for addition in the first place. So to do the dunder radd, you could check result vector bank self, and then you could just swap these two. I think all you would have to do and then return result. Or you could do it like ChatGPT is saying here and check to make sure that other is an instance of a vector and return it if it's not an instance of a vector. If it's a float or an integer, then you're going to just convert it. So that's all it's actually doing is under radd is just converting internally to a vector with some if statements if it's not, if it is. So you would have to just do a check here of saying if other is instance of vector, then proceed with this, or not, then convert to vector, then proceed with this, right? Sam says you could, in theory, use a try and catch and do other equals vector other and just call dunder add. Maybe. In theory, you could try a catch and do other equals vector other and call add. Yeah, definitely you probably could, I think, do that how you're saying, but I think we're just trying to keep it within the scope of the class initialization and that method. So like by calling add on top of add again would be kind of weird, right? Not sure. But yeah, that's a good idea. Good thought. Okay, so I think that is the answer. So what we can do is we can say let's sub. So we could try to like implement it here. Maybe we could say like this. So def under add, this takes in self and other, right? And then we're going to do this. Cool. So then what we can do is we'll say if length of self, right, does not equal to the length of the other list provided, then we're going to raise that value error. I'll just copy this directly. Okay. Okay, so if that else, we can elif, right, elif is instance, the first object is return whether an object is an instance of a class or a subset. So it'd be vector. So what is A in the is instance? A is in instance is the what you want to check and then what you're checking against. Okay, so actually it would be vector other here, then vector, right? So let me I'll just quickly copy this over so we can get rid of that error that's getting thrown. Okay, so I'll just put right here dot, etc. for the rest of the vector class. Hello, programmer. Thanks so much for joining and for leaving a comment. Appreciate you coming in. Just reading the Data Structures and Algorithms book in Python. If you would like access to the PDF, it's either you can just search it up online. It's by, I can't remember the authors. It's by 3 authors, or just simple. You could just join my Discord for free, no charge, no nothing, and this outlines all of the resources that I am using to self-teach myself all these programming terminologies and stuff. So that link is in the description if you want. But yeah, it's just data structures and algorithms in Python. So we check if after we get through this, right, we also want to check, not elif, we want to check if, we want to individually check if the other is an instance, right? We don't want to have do a secondary check. We want to have its own check here. If other is an instance, but would it be elif or if? What do you guys think? Sometimes I get confused on whether or not it would be. I think we want to say if here, but I could be wrong. If is instance other vector, then if that is true, then we want to is equal to false, right? If it's false, we want to convert vector of other, right? If, yeah, we want to hit it every single time. Thank you, Sam. So if is instance other than vector is equal to false, we want to then convert vector other into a vector, and then go ahead and perform the following. Now, would it be within this if statement that we would do it? If convert it to a vector, we'll save other as that. We need to save it, we need to resave it as other. And then within the if statement, do we then say all of the addition, the result equals vector length self, yada, yada, yada? Or do we have that outside of the if block to happen? Because we do the raise. This will happen if it's not true, and then it will go on to here. So the only stop is here. So I think it's okay to put it outside here, because we will get stopped and we can proceed forward if this statement is true rather than false. So I think we need to actually have it on the outside, because perfect, yeah, on the outside would make sense. So then we say result is equal to the vector length of self, right? That just gives us a blank result. And then we say for index in the range length of the self, we want to go ahead and say result at index value is equal to the self at index value plus the other at index value, right? And then we're going to just return result here. Perfect. So I think that takes care of it. Let me go ahead and copy that in. What do you guys think? Does this look pretty good? All right, you're on the right track, but there are a couple of minor adjustments to consider for optional functionality. Check other type. You're checking if other is a vector, and if it isn't, you're converting it into a vector. This works if you want to allow scalars or other iterable types like lists or tuples to be added to the vector, but there's a small detail here. Ensure vector other works. You need to be sure that other can be converted into a vector. For example, other should be a iterable or scalar like an integer. If other is not an iterable, it can't be converted or raise an error. Yeah, you might also consider directly handling the scalar case int and float earlier so that you don't necessarily try to convert scalars into vectors. I I think it's okay though because of this check, right? This check is really the determining factor to if we can proceed not with the value provided. Like it has to be a list of the same value, right? Because it has to be an iterable with length. I have is instance set to false here, so we can set it to other. We can actually convert if it's false, right? If it's not an instance of vector. Pardon me. Okay. I want to ignore that. I think that this is satisfactory because although it's not as robust as ChatGPT is liking, it appropriately handles the check because right off the jump, other has to be converted, has to be checked for an iterable, right? It has to be checked for an iterable and done a length function on it. And if it can't be given that, you get this value error right off the jump. And so just based on that information, if you tried to provide other as just a single integer value, unless your other vector was a single, your self vector was a single integer value, it wouldn't work. So I think that's fine. Okay. Sam says because you could also do is instance other list vector. Well, if we do list vector is equal to false. Oh, it has to be a list and a vector object. But by doing this length on it, we already determined that this is a list, right? It has to be some sort of iterable object. You know what I mean? Interesting. It's good thoughts, though. Dropping the false. Because that would check if it's a list and a vector at the same time. Yeah. Interesting. Okay, cool. Let's move on then. That was 211. 212 says implement the under mole method for the vector class so that expression v times 2 returns a new vector with coordinates that are 3 times respective coordinates of v. Okay, this one doesn't seem too hard. R 2.12 key.py rename, whoops, key.py. So this one doesn't seem too bad. Alright, like so, cool. So I'll just copy over that vector, dummy class, so we have this. Error not being thrown. Noah, thanks for joining. I appreciate you coming back, dude. Appreciate you leaving a comment and coming in. Good to see you. Good to hear from you. Okay, so that's fine. All right. Okay, so back to 212 here. Okay, so what we need to do is we would have to define the dunder mole method, and we would take self in this given instance, and you would multiply it by a value here, right? You'd be given a value to multiply it by. So then all you would do would be for return a new vector with coordinates. So new vector is equal to a vector class that is length for the length of the vector provided, right? Just like we did before. So we're creating a new vector that is the same length as the one provided in the instance self, but it's going to be just have blank zeros for all the spots. And then we need to, for value, for int, for I, for value in I'll change this to factor actually. So for value in the in self, right? We need to say actually for index in range length of self. So we want to get the index values for the for self, and then what we want to do is we could enumerate, actually use enumerate self and get the value as well, but we'll just say new vector at that index value is equal to the self at that index value multiplied by our factor, right? And then we're going to return new vector at the end of this loop. Noah Zyme says, you can't stay for long. No worries, so I appreciate you stopping in for a second. It's a Saturday night, so I don't expect everybody to be wanting to learn Python on their Saturday night like myself. No problem. All right, that's just the life of a study bug, I guess. So we return the new vector self. So I think this would work appropriately, because we have add or neg, which just takes the new negative and returns negative. So let's try this. Let's copy that in and see how that goes. Your mul factor is very close to being correct. Implements a scalar multiplication element by a factor. Here are a couple of things to consider to improve. Factor type. Your multiple assumes the factor is scalar. So it wants this. Oh boy, sorry. Oh, sorry. So it wants us to actually include a check on the factor itself to make sure that it is given in type int or float. Right, I don't think you can do that. Int, is it like this? Like that, I think. So I want to see if that is actually the correct way to do the type int. In 3. You could, and later you can use the int float as type int for a factor, but it's not supported in earlier versions of Python. To ensure compatibility with older version, you should use union from typing. Here's how you can do it. Oh, you have to use union. Sorry, I'm sneezing like crazy over here. What's going on? Something in the air. Hey Muffin, I appreciate you coming in and saying hello. Thanks for leaving a comment. I'm following the data structures and algorithms in Python textbook. We're on page 126 of 770, so seventh of the way there, but we are making progress little by little. That's all that matters, day after day, chunk by chunk, and then eventually it adds up and you're done later, 2 months down the road. So, but we're not focused on that. We'll just keep focusing on the chunks that we are on hand. If you want access to the book, you can either just look it up online for the PDF version, or if you would like, I have a free Discord with just kind of a mapping for all of the resources that I am using and have done to learn how to program so far, such as like CS50P. I have the Python crash course. Um, I have already read and done the Python crash course on this channel, and I have completed all of the try it yourself problems on live. But I have going back through and posting just individual answer solutions to those try it yourself problems onto the channel, and then I have my notes and things that I have. Um, like my personal notes and stuff on the book I've provided on the Discord and stuff. So it's if you want access to all that, it's completely free because I'm a beginner and other beginners. I want other people to have the same kind of resources, and I've kind of weeded out some of the stuff that isn't really all that great and stuff that is good. Um, Everyone talks about CS50, but this textbook isn't as popular. Well, yeah, I everyone talks about data structures and algorithms. People seem to have a lot of different methods to learning them, whether it be just online programs, online classes, or just textbooks. And I have found that I really enjoy reading textbooks and performing the in text problems that they provide. I didn't really value that growing up. I never read textbooks when I was in school. I always just learned from teachers and from trial and error. But looking back, the textbook literally tells you everything in the answers. It's just you have to weed it out yourself. That's the hard part. But by weeding it out yourself, I feel like you learn exponentially more. And it is challenging to read and get used to the flow of the terminology of the author at the very beginning. But once I've kind of gotten some practice through chapter 2 here, I've been moving pretty quickly, and it's been nice, and I've been understanding stuff. Obviously, using ChatGPT for additional help when I have questions about what the author was saying. But yeah, I've completed CS50P already, and I have a video on my channel that goes over my final project. But within my personal community Discord for the channel, I'm going to be posting um, individual answer solutions to the problem sets for my Discord members. I don't want to post them public to YouTube because I think it is against their terms of service as the class. I never paid for the course, I just did the free version, but I think I do want to provide to the small community additional help with my solutions to the answers because I do think it's helpful if you get stuck and just really can't do it to not just to actually learn from an answer is a viable way of learning. Obviously, you don't want to do it from the very beginning. You want to give it a solid attempt yourself. But yeah, so I'm going to make some personalized videos that are privated and linked on the Discord for the solutions to the problem sets that I have on my personal account for CS50P. But on my channel, I have a demonstration video for my final project, so if you want to check that out, that's there. But I appreciate you coming in here. Sorry for the ramble. Okay, so we have this now, and so GPT says that Python 3.10 supports the type hints of having multiple type hints with the bar, but 3.9 or earlier, you have to use the union from typing. So, yeah. I'm 3.10 though, so I'm going to keep it like this. I'll make a note though, like here, saying type hint support with Python 3.10. What was it called specifically? It was called I don't know, what's the bar called? Whatever. Okay, I think that answers that problem, no. Ooh, I'm dropping frames like crazy. What's going on? Ooh. My stream is really lagging here, guys. Hold on, I'm sorry. Let me go ahead and just wait for this to catch back up. It's really slow right now. Hey, how's it going? For those that are in here, how is my stream looking? It's really bad right now. It's on like 1,000 kilobits per second. It should be on 20,000. I'm sorry. I'm not sure what's going on. Let's see here. Why is my stream really buggy? What's going on? Why is my internet lagging so bad? Come on. Catch back up here. You got it. What's going on? Come on. Okay, I think it caught back up here. It's telling me I'm on excellent now. Now I'm on warning again. Shoot. Sorry guys, I'm not sure what's going on. Mo David, thanks so much. Mo Divid, thanks so much for coming in and leaving a comment. My stream is lagging really bad right now. I'm really not sure what's going on. If you guys can hear me, I'm sorry. I might have to restart. It's just really dropping a ton of frames right now. Um, Come on, what's going on here? Did I open up something on accident that shouldn't have? It's using a lot of bandwidth. Come on, what's going on here? It's really glitching here, guys. I'm sorry. Come on, what's going on here? Yeah, my audio's coming through fine, it sounds like, but my video is just really lagging here. I might need to restart the stream. Yeah, I'm gonna restart, guys. I'm sorry. Please, if you're here, just join right back right after this. It doesn't. It's just not working. It's just glitching for me and dropping all these frames.